Okay, so today we're talking about polygons. That's just a closed figure, oh boy, in a plane, formed by connecting line segments endpoint to endpoint, with each segment intersecting exactly two others. So each line segment is called a side of the polygon, and each endpoint where the sides meet is called a vertex of the polygon. Okay, so here on the left we have some polygons. On the right, these are not polygons. This one here has rounded edges, so that's what makes it not a polygon. Same thing here. It's got to be all line segments connected. Since this is just one line segment, it doesn't have any enclosed space. That's not a polygon. Here it overlaps. The endpoints don't match up. And here they cross over each other, so that's also not a polygon. Okay, so to classify a polygon, you look at the number of sides it has. So here are some specific names in this table. Take a second and copy those in. Usually anything bigger than 12, we don't see that often. They don't really have common names. If it has n sides, we call it an n-gon. So if a polygon had 25 sides, we would call it a 25-gon. Okay, so the word consecutive means in a row. So if we look at consecutive angles, well, angle A and angle B are in a row. They're right next to each other. Consecutive vertices, you could say here's C and D, those are in a row. Consecutive sides would be segment AB, segment BC. So in a polygon, we have to list the vertices in consecutive order. And when the polygon's a triangle, we have to use the little triangle symbol out in front. So if we look at this pentagon, if we're going in consecutive order, we could call it A, B, C, D, E. That time we went counterclockwise. Or you could name it any other point, pick a point, E, and then let's say I was going clockwise, E, D, C, B, A. And then we want to name the triangle to the right in two different ways. So pick a point to start. Whoa. You can name it triangle ABC or triangle CBA, and here it's super important that we use that triangle symbol. Okay, a diagonal of a polygon is a line segment that connects two non-consecutive vertices. So these ones are not right next to each other. So if you look at D, it's right next to E and G. So we want a non-consecutive vertice F. If we drew in this line here, we'd have a diagonal. If we also connected E to G, since those are non-consecutive, that segment there would be another diagonal. So we call a polygon convex if no diagonal is outside of the polygon. So here are all the convex polygons, the diagonals are all on the inside. We call it concave if at least one diagonal is outside the polygon. These polygons then go in like a cave, so that when you connect these non-adjacent vertices, the diagonal is really outside of the shape. Same thing here. These are your non-adjacent vertices, that diagonal is on the outside. Okay, so corresponding just means matching. So we've said that two segments or two angles are congruent if and only if they have the same measures. So we say two polygons are congruent if and only if they have the exact same size and shape. And when I say that if and only if, it means that the statement works both ways. So I could say if polygons are congruent, then corresponding sides and angles are congruent. Or I could read that statement the other way. If corresponding sides and angles are congruent, then the polygons are congruent. for example, if these two quadrilaterals are congruent, then they have 4 pairs of corresponding angles and 4 pairs of corresponding sides that are also congruent. So when you write a statement of congruence, you always write the letters of the corresponding vertices in the order that shows the correspondence. So if we wanted to write a statement of congruence for the two quadrilaterals above, okay, we need to find things that are congruent. So if I look at angle C and angle S, here's my congruent statement. I'm saying something is congruent to something else. Got to find those matching parts. If I look at some sides, here side MA with 3 tick marks would be congruent to side TI with 3 tick marks. Okay, so which polygon's congruent to A, B, C, D, E? Well, we need 100 degrees with sides of 2 tick marks, 130. So that would be this pentagon here. Oh! Sorry for the sneeze. Then we have to match up these corresponding parts. So angle A matches with angle Q here. They were both 100, so I start this with Q. Then they went to B, so we can go to L, then down to M, N, and P. Then we have an equilateral polygon. All the sides have equal length. In an equiangular polygon, right, the word angle is kind of in there. All the angles have the same measure. And if we have something that's regular, a regular polygon is both equilateral and equiangular. So in these examples here, this first octagon is equiangular. All we know is that all of the angles are congruent. Here in the middle octagon, all of the sides and angles are congruent, so that makes it equilateral and equiangular, so we call that regular. And in this last octagon, we know nothing about the angle measures, just that the sides are all congruent, so we call that equilateral. Nice.